Welcome to Lecture 6.2, and today we're going to talk about the interaction among constraints. And this is from Chapter 18. Just to go over a quick outline, we're going to recap the constraints. We're going to talk about manipulating constraints to aid motor development. We're going to go over an ecological task analysis, and we're going to talk about our assignment. So just a quick recap of our constraints. We've talked about our constraints for pretty much all of the semester, but just go over them again. The individual constraints are structural and functional. Structural are body structure related, so that's physical size, and functional are behavioral, so that's more of the psychological aspects of it, such as motivation or desire to perform the task at hand. Environmental constraints are sociocultural, and they're also physical environmental. So sociocultural would be what we went over in the previous module about how society and the cultural aspects of it shape the environment. And physical environment is stuff such as gravity or the surface upon which you're running. Task constraints include the rules of the sport that you're doing and the goals of the movements. So constraints are very important because all aspects of development are influenced by multiple constraints at any point in time. And by looking at a motor skill from the constraints perspective, you're encouraged to see each individual as unique. And it helps inform the design and implementation of developmentally appropriate learning tasks. So, an example of manipulating constraints would be the London Paralympic Games. Since there are about 4,302 athletes in 162 countries and 21 different sports, and each individual in the Paralympic Games has a different set of constraints that they're working with. That being body, many times it is body structure constraints, so it'd be an individual constraint that they're working with, as well as sociocultural constraints. And these can be manipulated in aspects such as the athletes with additional equipment, or in the sports itself where the rules of the sport can change. So an example where the athlete is manipulated here is in track and field. So since this individual has a structural constraint of not having use of her limb below her knee, they've created a prosthetic leg in order to manipulate her body structure so that she's able to run. An example where the sport is manipulated is, in this case, wheelchair rugby. So for individuals who are unable to independently locomote themselves without assistance, the wheelchair rugby allows for them to locomote using an external device while still being able to play the sport. Wheelchair tennis is another example of a way to manipulate the sport itself. And so the way that we can think about this really is that anytime the athlete is manipulated, their body structure is changed. Anytime the sport is manipulated, the rules of the sport change. So you think about it as any sort of wheelchair sport or any sport where the rules themselves are no longer the same. So when we're adopting Newell's triangles of constraint, a different geometric shape can be used to represent more constraints. So if we look at it from a, I think it's a hexagon, whatever is a six-figured object, geometry is not my strength. But from the individual, we can see height and strength are two things that are something that we have to look at here. From the environmental perspective, the basket height and the size of the ball. And then the task at hand is the goal, which can be the ball goes to the hoop, and the goal can be a one-handed set shot. So when looking at a missed shot or an incorrect performance, we have to look at all of these factors rather than just looking at the three. You got to break them down a little bit more. So teachers and coaches need to identify which constraints to change to elicit the desired movement. So for example, if we are looking at a small little 5-year-old trying to play basketball here, the best way to create a successful shot is to reduce the ball size in this example, or possibly even the basket height, so that we can now have a successful shot, because the ball was the constraint that we can change in order to make the performance more successful. As students grow and mature, constraints can be changed in proportion. So we can change some of the constraints at different times. So, for example, with tennis, when you start the children off playing the sport, you use lighter balls, you use a shorter court, and you use a smaller racket. So as children grow, you tend to give them a slightly larger court, you give them a ball that bounces a little bit more, and you give them a bigger racket. And this increases all the way until they've reached their full mature body size, because the goal still will remain the same of trying to hit the ball over the net into the court and beat your opponent. So for an ecological task analysis, you need to analyze how a particular task or skill is accomplished by focusing on the critical components that influence the movement. You have to emphasize the interaction of the environmental, task, and individual constraints. And this allows professionals to create developmentally appropriate lesson plans and assess movement ability. An ecological task analysis also evaluates movement based on the developmental continuum, rather than labeling a movement as correct or incorrect. So what we did in the previous slide was really an ecological task analysis, where we look to see what parts of the task constraint we could change in order to account for the smaller individual body size. So constraints can be also converted into column headings. So going from a continuum from easy to hard, we can break down the environmental constraints, task constraints, and individual constraints in order to manipulate them so that we can make the motor performance successful. So talking about our assignment, the instructions are on D2L, and there are a number of case studies listed. For each case study, identify a potential constraint involved in the movement or sport. Consider individual, structural, and/or functional, environmental, and task constraint. For each constraint, state whether or not it can be modified, and if it can, provide one example of how to modify it. For example, an individual constraint of body size is not really something that can be modified because, well, for a child at least. For an individual with a disability, you could modify the individual constraint by having them have a different leg, for example. Anyway, you have any questions at all about this assignment, shoot me an email. I think it's pretty straightforward. It should be fun and allow you to really apply what you've learned so far in this course. Have a good day.